All right, let's finish up the solubility PhET here. This is the last part. It is an extension part. I'd encourage you to do it just because I think it's really, really helpful in helping you understand what's going on. So first off, what we're going to do is we're going to look at the micro part of the tab. So if you're looking at the simulation, we're going to click over from water, where we've been for the last part, to micro right here. And you'll notice you can click through and look at different solutes. Solutes are things that dissolve in water. So we can look at all sorts of different stuff. And I'll come back to what that looks like in a second here. Let's switch back over to here. So what I want you to do is I want you to make a prediction and think about ionic is when a metal and a nonmetal comes together. We talked in previous lessons and thought about the differences in conductivity and solubility between ionic and covalent compounds. So I want you to think about all of these things here are things that are going to dissolve. I want you to make a prediction about whether they're going to break apart or stay together. And then we'll go through and we'll look at all of them as observations. So I'm going to look at these 5 substances. And once we observe them, you're going to determine whether it's an electrolyte or a non-electrolyte. And I want you to think about if it's ionic or not. Is it metal and nonmetal together, or is it just nonmetals? There aren't any metallic substances in here, things that are just metals. But I want you to think about which ones are metals and which ones are nonmetals. And just in case you need a little bit extra on that, remember that metals are the stuff on the periodic table that's all on the left side here. And even some of like these things down here at the bottom. And this kind of top right area is the nonmetals. So like carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, things like that. All right, so come back here. We're going to go over to the simulation. Maybe do your work, make your predictions really quick, pause this video, and then I'm going to move it over to the simulation here. All right, so sodium chloride, as we're going to shake it in, boom, 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 boom. What is it doing? Is it breaking apart? And we come over here, we can look at the concentration. We have sodium ions and chloride ions. So that one did break apart. Let's think about sucrose now. I'm going to remove this solute from the water. So sucrose, I have these sucrose molecules, and I can see in the concentration that they stayed together. They don't break apart into carbon, hydrogen, and oxygen. So that's something for us to think about. We've done sodium chloride, so now I'm going to do calcium chloride, right? And when I put that in, I see, yep, looks like my calcium ions separate out and my chloride ions separate out. So calcium chloride separates out. Go to the next one, sodium nitrate. All right, so I have sodium ions. This one breaks down not quite the same way as the others did. I have NO3. So you might remember when we were talking about ionic naming, we talked about monatomic ions. NO3 is nitrate. It is a polyatomic ion. It's an ion made of 1 nitrogen and 3 oxygen all bonded together, but overall it has a negative charge. So there's that. But I do notice that it did break apart into sodium ions and nitrate ions. All right. And then finally, we're going to come over and we're going to look at glucose. So glucose is a different type of sugar. You might have heard of it in photosynthesis. It is C6H12O6 rather than C12H22O11. So again, think about what kind of substance is this. And notice that I do just have glucose molecules floating around in here. It's not breaking down into carbon, hydrogen, and oxygen. So there's our observations. Do you think it's going to be an electrolyte or a non-electrolyte? And do you think it is ionic? Yes or no? And then here you're going to draw or at least describe in as detailed way as possible what happens when you put the sodium and the chloride, or sodium chloride, into the water, the salt. And then think about question number 10. Electricity is the movement of charged particles. And what do you think is happening for an electric current to happen in here? Maybe think about what charged particles are moving. All right, with that, I'm going to shut this off. And you've got this. That's the end of the solubility PhET. I will see you back in a bit for the electrolysis of copper chloride lab.